So this big data analytics, it has two parts. One is the big data, other is the analytics. So what is big data? To what we used to say big data? Is there any formal definition of big data? Then what is the analytics? If we talk about big data, then it is expected that you have understanding about the term data. And because you have gone through two courses, you have studied two courses, database management system and data mining. So I expect that you have some good understanding of the term data. Even though for refreshing your memory, I will take 2 minutes to explain this term data. Okay. So we start, suppose I write on a screen, I have written one number on your this word file. So it is showing number 20. Everybody understand this 20 is a number. And if I ask how do you come to know, an answer will be because you know the number system, you know the counting integer. So even the answer can be given by a small baby, school, nursery class or first or second class. But if the baby is not knowing any counting or number, then the answer will be no from his or her side. And they are symbols, they are zigzag sketches. Right? So when I say this is 20, so answer is it is a 20 number integer. If I add here 20 years, so now what is this 20 years? Then because you know 20 years, it is a period duration. So one can guess it may be age of some person, okay? It can be duration or 20 years period describing something about so and so. If I write here, now age 20 years. Now it has again some more meaning has been added. So earlier it was 20, then 20 years, some meaning I have added. So compared to 20, when I write 20 years, I add some meaning. And when I add age 20 years, further I have added more meaning. And if I write here, Ram age 20 years, further I have added more meaning. So every time you see here, I am go on adding some meaning more and more, right? So if somebody say this 20 is a data, then question will be how do you define it as data, on what basis you say data, okay? So if we want to understand, we take example of biodata of a student. In biodata of a student, what we have? We have name of the student, age of the student, father's name, mother's name, address, qualification, etc. That means the biodata basically refers the details or some information about the student, his profile. Okay. But inside data, what we have? Some age, date of birth, some father's name, etc. So biodata is providing me the information. And biodata includes the data. Everybody understand. Even in data sheet, we say we have the data. Okay. So basically, if you ask what data is, then you will observe around your in this in your surrounding or in this whole world. everything may be supposed as data. My name can also be considered as data. Your name can also be a data. Even in my roll sheet, I have roll number, your name, they are the data. In your answer sheet, you have the subject name, your marks, that is data. And as a whole, somebody asks what is the your grade in your BTech, so and so, then you will say 7.8 GP or some grade, or somebody will say 80% mark. So 80% is also data, and marks in each and every subject out of 100, they are also data. Okay. So at what level of detail we are talking? So one thing you see, from data we have some information. When I say biodata of a student, then you say biodata is providing me information. So can I ask question whether data is information or information has data? So answer will be somewhat some it requires some kind of reasoning, and you will see here. The question will be to what we used to say information and to what we used to say data. So basically, when I say I am getting information from the biodata of a student, that means information has somewhat more meaning. Okay. So if I write here information as data plus meaning, data plus, data plus meaning. In my biodata, I have some data, and as a collective form of this biodata is providing me the information about the student. Somebody will say whether this 20Y also has some information. The answer will be yes. Information is there, but very little information. Or no information. Somebody will say this 20 has little information or no information. So one word I also used to in here that we call raw data. Raw data. Raw data means data that has either no information or has very little information. Raw data you can make analogy with the raw material. Suppose when we take out the raw material like iron or other metals from the ground by mining, and then we process them. So raw material cannot be directly used, but after processing raw material, we prepare several kind of different products, and those products have the utility. Similarly, we can say data or raw data, they do not provide directly any information. But after processing of the data, we have some useful information. And when we say, how do you define that it has information and it has no information? Then again, answer will be whether something is information or not, it will depend on our own understanding. Okay. In the real world, things do not have their own identity. We, human beings, assign the identity. We define the things and we use them. So if you observe this whole world, everything physically is present outside, but inside at our understanding level, they are abstract. They do not have their own physical existence inside our mind. We consider them abstract. So from human understanding point of view, everything is abstract, but physically in real world they are existing. One can also say it is a kind of mapping also. Okay, so there is one subject that is called ontology. Ontology basically it is a branch of philosophy, and this knowledge domain it work only what are the concepts, how the concepts are defined, how concepts are related. So many things. Basically, it is related, and this subject ontology is also useful here in our this information system, etc. So two things are very clear. Data means raw or no information, very little information, and information means data plus meaning. Meaning is associated. Okay. So when we say big data, so how do we define data is big? Big means physical size, physical dimension. What is significance of the meaning of this word big? So we will discuss. And then what kind of processing can be done? So basically, if you ask, then it is easy to understand big data. So here, one more thing I would like to add. Database, you understand collection of data. So we are not going in detail about it. And you also know this database management system. Okay? So management system, it is a system that manages database. Okay, several databases are there. MySQL popular relational database. Okay, so I expect by up to this you have clarity. And now we come on the topic of our big data. So first of all, I acknowledge the author who has prepared these slides, and I have also taken permission. So big data analytics and big data analytics. In this slide, we have very good pictures, images, and it helps in simplifying understanding. So what is covered in big data, data concepts, then big data concepts, then big data life cycle, and the analytics concept types and advanced analytics, traditional and advanced. Then the big data analytics, how? So we discuss first one by one big data. What is it? Okay. So something is written here. So first I read the slide, then we will come. Data are the raw facts. Real world, everything is taking place in terms of facts. So we use the word fact. Data are raw facts or description of facts. Okay. Ontology also deals the description of facts that were taken, observed, recorded, agreed, such as words, numbers, observations, surveys. Okay. Based on our observation, based on our uh, collection of data or something we are agree. So we use the words or some way of representation, numbers, etc. All these constitute data. So data are unprocessed facts, figures, schemas, okay, unprocessed. Processing has not been done, just like raw material directly from the mine, collected or discovered directly from the mine or underground of the earth. And directly it is not useful, but after processing, we can make several kind of useful things or products. So data are unprocessed facts, figures, schemas. In information system, here information system, we are talking computerized information system. Data is input to the computer system. Okay, so data does not have a meaning. So when we say does not have a meaning, means it has very little meaning. Ideally, it is not possible to say it has no meaning. When we say no meaning, that means we cannot even write the 20 as number. Okay? So little meaning. And it is also shown different sources on the slide. Several sources are shown here and data are generated. Okay, we can store. Data here, two kinds of data have been written, but depending on there can be several different types, but temporarily we assume these two types. So it is written textual or symbolic. Okay, and quantitative, numerical. So qualitative and quantitative. Qualitative generally a term we use, suppose to describe the qualities, we use the term good, bad, better, etc. So description is given in those terms, low, high. Okay. So then we use the qualitative explanation, and when we have number, then it is quantitative. And we can use different kind of methods. So it is written concept, definition, methodology, analysis, result. Collected by measurement tools or machines, collected by observation, analysis performed by statistical and numerical methods. For quantitative and for qualitative, performed specific adapted methods, classification, quantification, etc. Result, report, or statistics. Okay. So now again it is shown here, it is written 24-degree. Here it is said that 24, it is a data, 24-degree. But other details are hidden here. Okay. It is temperature, of what temperature it is, what is the purpose. So here it is data, but if I add this information, 24-degree and 24-degree a temperature of weather at Strasbourg, it is name or it is a city in France on so and so date. Now this explanation is information to me, and earlier it was 24-degree. Suppose you are standing here in Kurukshetra and we are talking about the temperature. Today temperature is 24. Then the other person need not to know to what the temperature is referring. Automatically we have understand that we are talking about the temperature of this Kurukshetra city. Okay. So if the person is not here and it is on mobile, and if I say 24-degree temperature, so other person can have guessed that the local temperature I am speaking. Otherwise, he will or she will ask to temperature of what. So sometimes we have very limited words in communication. It is because something we understand already, whatever assumption or what we presume. Okay. So here 24 degree, and if we add that, it is information, right? And one more thing here, when we say 24, meaning contest temperature of what, it is not mentioned. So when we process data, then we have information. Okay. So raw facts were taken, observed, recorded, agreed. So simply one can understand from this picture. So nothing to explain. Same thing. Similarly, when we process information, then we have something that we call knowledge. Okay. It is also shown here, data and processing of data, and several kind of different information. And we can process information, we have some kind of knowledge. It is representation of the knowledge, some the links, the connection, relationship between the this information. So then we have knowledge. It is ontology written here. Ontology basically, it is the name of the subject. It is a branch of study of the philosophy, and here we understand or describe. So it is written, there is ontology defining the definition of meaning that frame the set of information. And here it is written, knowledge is a set of relationships between information elements following an ontology. Mapped information, how they are related, what is compound in what, where. On the internet, you will see ontology of different subjects also you have. Medical ontology. Ontology generally is prepared for one specific domain. Okay. So if for better understanding, you can go on net and search this ontology. Ontology is also covered in our computer engineering subject. This is showing you, this picture is somewhat more clear. Temperature, 24 data is collected, and we have processed it, and it is showing temperature of weather on so and so date. Okay. And this our mind process this information, and based on this information, we decide whether I should go outside for walk or not. So this human mind is shown here. So we take decision based on the information. How good information you have will decide the quality of the your own decision. So we always try to get right, correct information. Okay. So right information, right decision. Now, big data. What is big data and how we define the big? You see here, today we have social networking sites. Okay. Twitter, Facebook, etc. We have on WhatsApp. Earlier, all those things were not in this digital form, right? Today we go for online purchasing also. And because of this digital world, lot of data is generated and continuously go on generating. And this has provided a question how this huge data may be managed. And earlier, we have database technology only. Relational database technology was popular, and that relational database, they were developed keeping in view the business requirement, commercial business accounts requirement. Basically, in accounts we have very big sheet and reports, and they have tabular format. And this relational data directly map represent those kind of business or commercial data. And to satisfy those requirements, the technology was developed, relational database technology, and it is much matured today, and it is very useful even today. But today, new this kind of data, and this data is not like relational data. So that technology cannot be directly used here. Okay. So we have structured, semi-structured data, text data, okay, image data, web data, social networking data. Data itself have different kind of formats, variety. And we have to manage, we have to store this data. So storage issue one there. And after storing, we have to manage and process. How this data can be processed and how we can get the useful information. And because data is so big, so sometimes it may take 100 years to process them. And if some data that I process today, and if the data will give me some information after 100 years, and my life is not so long that I could wait for 100 years. After, suppose if I apply on myself 20 years, 20 years, I may be somewhere else. And so one solution, I need not to process such data, because I will not alive by that time, so I should not bother about it. Second, I would devise the technology, because I will not be there, but other people will be there. They will use it. So, if I ask you by apply your common sense, what are the solutions to deal such big data, so that I could process it in time and it can be useful? So, two common solutions everybody will have. We should process data in parallel. And instead of using one machine, we should use several machines. Okay? So some kind of parallelism can be done. So when we have several machines, then those machines should be arranged in a distributed area. So one is the distribution. Computation can be distributed on several machines. Okay? And the processing can be performed in parallel. So distributed and parallel, two components we have. Distributed and parallel processing, if we apply, because nowadays we have low cost of hardware, so I can purchase thousands of computers, thousands of nodes, and I can afford the processing on those thousands of computers. So because hardware cost is uh, low and go on decreasing day by day also. Even memory storage cost is also going to decrease day by day. And the capacity of device, it will also go on increasing. Okay. Earlier, I about 20 years back, when I purchased pen drive, it was 500 megabyte. And today, later I purchased pen drive, it was 8 megabyte. And 2-3 years back, I purchased, then it was 32 megabyte, 32 gigabyte, GB, not megabyte. 500 megabyte, then 8 GB. Then now 24 GB. So mega, then giga, then something else. Okay. And if I go back, then we used to one disk 1.44 megabyte. And if I go further, then in the beginning, when I was a student like you, then we have a personal computer, and the personal computer hard disk has the capacity of 20 megabyte. 20 megabyte. Hard this this hard disk of the computer. So you will see in the slides how the memory size go on increasing and how cost is also go on reducing. So storage problem is solved and processing problem will solve. So now question is how this can be done comfortably. So several solutions have been proposed. Hadoop is one solution. Spark is another solution. It is called framework. So it provides the facility. By using the framework, you can perform parallel and distributed computation or processing. Okay. And similarly, Spark is another further improved version, and here we can have similar distribution and parallel processing. And to for a framework, we require several software, and those softwares are also used here. And for one specific purpose, one software has been developed. So we call tools, and all these solutions are open source. Okay. So by using this open source, we can even solve any kind of problem. So here analytics analyze volume, market, model, Facebook, web, variety, management. Analytics word I will tell you. Analysis basically the word is analysis, but generally we have subject name electronics and suffix we use. Two kind of suffixes generally in English for subject name: psychology, logy, terminology, okay, and electronics, physics, mathematics. So x suffix. So they have given analytics. Basically, analytics it performs only the analysis. And if somebody will ask what is the difference between analysis and analytics, only one difference we can observe here. In analytics, we do the analysis, but here analytics domain, time domain is past, present, and futures. That means we consider or we can consider past data, we do processing in present time, and we make prediction for future time. So lot of data we have, past data. In present, we do the processing, but the objective is for the future time. You can also do temporal or present time prediction, no doubt, but objective is also included future. Okay, so if we do such kind of analysis, then generally this analytics word people are using. Okay, they are the words. Earlier I told that words they do not have their own meaning. We people define the meaning. Okay, so as the people have defined, so we are also with the people. This is data, big data. So some definitions are written here. I read the slide, then I will come. Big data is a of field that gathers all activities and functions of acquisition of data, storage of data. Okay. Acquisition means collection of data and store. Okay. Then from multiple sources that cannot be processed by common or traditional system, for example, ERP, Excel sheet, relational database, etc. In big data, we have this 4V term is used to define big data. Huge volume. First V is for volume, second is variety, third is velocity, and fourth is veracity. Okay. So volume is huge. Second, variety of data is there. Okay, heterogeneous, and we have a very fast rate we are getting data. So velocity is incorporated, and uncertain. Uncertainty means veracity. Basically, this word refers to same meaning as we have integrity in relational database. Actually, suppose my name is SKjan. So if you go on searching internet, you will find several people with the same name. Now, question is whether to whom I was searching, this is the same person SKjan or different one. So somebody, how to authenticate it? Your data should be truthful, or data should be true, or how truthful it is. Sometimes you see up-to-date information word also used here. My profile, if you see, it was 2 years back profile. Now, what is the current profile? So when we have a lot of data, then we have question whether this data that I was expecting or I require is up to date, current, latest or not, or it is as per my requirement. So that kind of uncertainty may be there. So they use this word veracity. Okay, but it has no new meaning. Only how true the data is, truthfulness. If you talk about in terms of adjective. So it is shown here volume. This is 2012, 13, 14. Okay, this much volume of data we have. Data traffic, exabyte per month. Evolution of data stored and exchanged over time. This is the volume, 8-bit, byte, kilobyte, megabyte. Now unit is gigabyte. Okay, this much. This is simply showing gigabyte, then terabyte, petabyte, exabyte, zettabyte, yottabyte, itna byte. Volume, all over the world, data is distributed and we collect. Today there is no issue of the at which place you are. You can collect data from anywhere. And because of this volume, we store data, so many computers here, data center. You see, they are basically nodes we call, but they are the computer. They have processor, they have memory. So they are the computer centers, data center. Now we have word data center, data center. You can imagine the volume of data here. This is written something volume, storage price. Storage price go on decreasing. Earlier the cost was very high, 1990. So Now this much. Volume, virtualization. Now you see here, physically people are here in this country, in Australia, in America, France, or and the different kinds of people are at different places. Okay, manager is here, desk, help desk, finance, developer, user, customer. So basically, it is like a virtual world. Okay, a cloud computation, cloud means remote computer where we store. So okay, simply nothing to explain. Picture is clear. We have data today not from computer. We have data from vehicle. We have data from mobile. We have data over other Internet of Things word you will see. And data types, we have variety of data, several format of data representation we have. Today we have different kind of file format. So no standard format of data in storage, metadata of structure or, and organizations, semantic data, image data, video, text, XML, text format. So big data have to deal all these kind of variety of formats of data. We are getting data from different variety of sources. And we define basically three kinds of formats: structured, tabular format, unstructured text format, and semi-structured between these two. Here they have written structured and unstructured data. Okay. Transaction report, database file, table. Variety of data. So all these variety of data have to store here. Structured and unstructured too. Velocity, simply at a very high rate we are getting that. 1G, 2G, 3G, 4G, 5G. Okay. Speed of data flow is go on increasing because of IT, high progress. Veracity. So veracity here, obsolete data it is written, important data not yet digitized. Okay. Archive. Velocity, uncertainty of data on certain multi-channel sources, multiple profile. One example I told, my profile on institute website, my profile on my personal website, my profile on Google website, my profile on Facebook. So one person and several places have the profile. Now question is which one is correct? So if in ideal case, if I update my one profile, all the profiles at different sites may also be updated. Okay. In ideal case. But if there is no such kind of system, then somewhere I have up-to-date profile, somewhere I have profile 2 years back, somewhere I have profile 1 year back. So uncertainty of data. So this is a kind of uncertainty. So fake profile on social network, multiple profiles, which one is correct? So false data, generally nowadays people keep false data on their social networking site. Do they want to maintain some kind of secrecy? But in the beginning it was not so. In the beginning of social networking platform, everybody was happy to share information. Now, because of security and some personal issues, people go on again some kind of security management of their data. Uncertainty of data, uncertain, multi-channel. Second, data is coming from a machine. If your that machine is not working properly, you may have wrong data also. So that is also one issue. Uncertain by nature. So veracity, uncertainty of data, uncertain, multi-channel sources, forecasted by nature. Meteorology, road management. Big data life cycle. Basically, you know, in software engineering, software life cycle from requirement analysis up to production, installation. Uh, so first we go requirement analysis, then design, then coding, then implementation and installation. And if software that is to be delivered, now it has new requirement by that time, then again we have to go for development cycle. So this kind of life cycle can also be defined here in big data. So data acquisition, and then data store, then processing, then information, then decision. Okay, now decision have been taken not appropriate, some more data is required, some more kind of analysis may be required, like that. And we also observe life cycle in nature, water cycle, then nitrogen cycle. Okay. And if we assume reverse concept, then we are also in birth cycle. So big data life cycle, data acquisition, data storage, multiple channels, Internet of Things, cloud or varied computing, then database, data warehouse, lake data, data security. This is data acquisition, collection of data. So data is collected from different sources. Is a processing of collecting, cleaning, and filtering data before data is put in storage. Before storing data, some kind of processing may be required here. So this picture is showing here raw data, cleaning, collecting, filtering. This is now this data can be stored and it can be used for further processing. Multiple channels. We have data from different kind of sources. So Internet of Things, we can have data. Okay, we can have continuous stream of data. Even this we are I am taking this lecture class, so it is a kind of stream data. Then you see here transaction, batch processing, okay, and here data warehouse. Here this new word data lake is written, so that I will explain in a short while. Multiple channels data streaming is structured and unstructured data mainly from Internet of Things. Okay. Batch and event sourcing data from infrastructures mainly from cloud and on-pro. Real-time data flows, real-time, near real-time flow mainly from Internet of Things and cloud. Data transactions, structured data mainly on-pro. So data sources are different, data formats are different. Okay. So Internet of Things, this is a smaller embedded chip or device. The Gartner, basically it is a name of company, okay, that provides some kind of services. So it is not any kind of, it is a name of company. This small r is also written here, registered. So Internet of Things, a set of devices that are able to connect and exchange data through internet. So Internet of Things means if I make a unique identification of things, any kind of thing, my washing machine, my fridge, my room heater, okay, all these kind of appliances which are used at home, if I make unique identification and if they are also connected with internet, then this structure will called as Internet of Things. Okay. So by making unique identification, I can provide several kind of facilities. Okay. And I can also use some kind of software. Such software generally they are called embedded software. That means the software is inside the machine. It is embedded in the machine. So I want to manage my suppose air conditioner from distant place, okay, and if it is connected by net and it can be identified uniquely, okay, then I can send my control signal from a distant place, and based on the control signal the my room, my air conditioner will interpret it, okay, by its local embedded software, and based on the software the instructions either switch on or switch off and temperature control they can be done. So in this way everything, every such device that we require, that we want to use, can be managed. Now that device has its local memory, its processing unit. So it will depend on the requirement. Okay. So you will see here, this company performs business of this embedded computing. Embedded computing more than $1 billion US 2021. You see here, smart washing machine, smart fridge, smartphone, smart assistant, smart watch. You know, if you understand this word smart, what is smart? Okay, we are using with each one. If I talk my mobile is basically it is a phone, handset phone. Its core objective is to communicate with people. Okay? But some more features are added here. Suppose net facility is providing to me. Suppose I can email. Okay. Some camera is also installed. I can take picture and process picture. That means core function is retained, that is the communication, and additional function have been provided for my uh, to make it useful to me. Now, this mobile is now more useful to me. It is not only providing me communication facility. So earlier it was telephone or mobile phone. Now I can say it is a smart mobile. So a smart word is referring simply some additional feature function. Earlier, this was providing only communication facility. I can talk. Now it is providing somewhat more features. You see, when we say sometimes this student, this boy, this girl, it is smart. So, what is meaning here smart? Only meaning is that compared to other person, this person has some kind of extra uh, ability, extra competency, extra something extra is there. But we don't know that extra in what sense we are talking. But here, in for the devices, we simply say, if I say it is a car and it is a smart car. That means this car may have so and so kind of facilities, so and so kind of features. It is a fridge, it is a smart fridge. Okay. Similarly, it is a watch, it is a smart watch. So smart word today is being used for this purpose. Okay. So smart is why it is smart compared to the conventional. Tomorrow something new will come, then that will be smarter than this smart. Or somebody will suggest new word for that. So these are Internet of Things. You see here, a smart car is there, a smart drone is there, a smart printer is there. Okay, so printer, my printer is also here. Its basic principle is to print, but it is also providing me the facility of scanning, the facility of photocopy, the facility of fax. So if I compare my 20 years back printer, then I will say it is a smart printer. So this RFID today everybody use it on vehicle. So it is basically based on radio frequency. So what we used to do, this device when come or interact with the area electromagnetic radiation. So when it comes in interaction with the electromagnetic radiation, it generates signals. Okay. So RFID is radio frequency ID. So it corresponding machine we call RF reader. So it reads and based on its detail, the money is deducted from the account as toll tax. So tracking smart manufacturing optimization, and this ID can also be used in stores, departmental store, to somebody to stop theft. Okay, so anti-theft purpose. So if somebody takes it out, some product outside the store, immediately some alarm will be on. So it is logistics tracking, smart manufacturing optimization, smart product. So this is also one use. So you see here, all these smart products, they are generating data. Okay, all these are part of the big data. Big data covers each and everything. Now you see
Excuse
here,
me, sir.
yeah,
So sorry for interrupting, but अभी हमारी next class है.
okay, I am just closing. Okay, yeah.
Okay, okay, sir.
Smart this BP measurement machine and this other health devices. Okay. So I stop here, and the rest we will discuss in next class. It is a very basic, just introduction of this course. Okay, thank you.